I'm going to try to teach you hyperbola stuff really quickly here, and we're just going to go starting at number 7, and then we will refer back to the picture of the stuff that you have for the hyperbolas as we do it. But bottom line, this has two squared terms as well, okay? Parabola had one was squared and one was not. An ellipse had both squared, but they were both the same sign. So if this is minus, this would also have to, the 4x would also have to be minus. So if these are different terms, then you get a hyperbola. But they work the same way. Well, they start off working the same way. Minus y squared minus 4y. I'm going to throw the 16 to the other side. Okay, so I'm going to complete the square here. Again, we have that problem with a 4. So x squared minus 6x. Take half of this number and square it. That's 9. Do you see how you really added 36 to this side? So you're going to add 36 onto the other side. Okay, here, this is my concern for you is that you won't remember to factor out the negative. So factor out the negative, you have y squared plus 4y. Take half of that number and square it. Okay, but do you see how you really, when you multiply by the negative, you really added negative 4 to this side? So you have to add negative 4 to the other side. So I have 4 times x minus 3 squared minus y plus 2 squared equals, all right, 36 minus 20 is 16. And then remember right here, just like on the ellipse, this right here has to equal 1. So I'm just going to divide everything through by 16. And I have x minus 3 squared over 4 and y plus 2 squared over 16 equals 1. Okay, from here, a lot of it seems the same. The vertex, or really, it's not really called the vertex, it's really called the center. Okay, the center is 3, negative 2. So you're going to go over 3 and down 2. There's the center. Okay, you're still going right and left the square root of that. You're still going up and down the square root of that. 1, 2, 3, 4. And 1, 2, 3, 4. Okay, now that's where this changes. Okay, so with an ellipse, I would connect all these dots. With a hyperbola, okay, this is weird. You actually have to make a box. Right here, you make a little box, and then you draw these diagonals of the rectangle, and those are asymptotes. And so now you have to determine which way this goes. Okay, so I'm looking at this. Basically, if the x is the positive one, right, the y, see how that's the negative one? If the x is the positive one, it starts at these 2 points, and it goes toward the asymptotes. Starts here and goes toward the asymptote. If the y, if these were swapped, and the y was a positive one, then it would have started here and gone up, or here and gone down toward the asymptotes. Okay, so the difference between graphing an ellipse and hyperbola is for an ellipse, you connect the dots with a circle, with an oval, and with a hyperbola, you connect the dots with a rectangle, and you go from here. The foci are always inside the bowl, so the foci are somewhere in there. And so on this one, c squared equals a squared plus b squared. Okay, so if this is a minus, this one is going to be a plus. So I have 4 plus 16 is c squared. So c is plus or minus the square root of 20, which is plus or minus 2 squared of 5. Again, to find the coordinates of these foci, you start here at the center. Okay, so you start at 3, negative 2. Do you see how to go this way or this way? It's affecting the x value. It's not, this y value is going to stay the same. But from that 3, you're going to go plus 2 squared of 5 and minus 2 squared of 5. And those are going to be the two equations of, or the two foci. Okay, so you know the center, you know the foci. You have something called, these are called the vertices here, those 2 points. Okay, the connecting axis is called the transverse axis. The other one is called the conjugate axis. So this one right here would be the conjugate, but the transverse axis is going to be what connects this. So if the hyperbola had been going this way, then this one would have been the conjugate axis, but it wasn't. All right, to write equations of the asymptotes, and this is kind of a little bit weird. It's all based on the fact that y equals mx plus b. Okay, so all you're going to do, you're going to end up writing, we're going to put it into sort of the slope formula, the y minus y equals slope times x minus x, right? That's like just this one's slope-intercept, this is point-slope form. Okay, so you're going to put in your center, and your center was, 3, -2. Okay, so x minus 3, y minus -2. So that's going to go here. And then look at the slope. The slope is going to be, do you see how you went up some and over some? It looks like you went up 4 and over 2. So when you go up 4 and over 2, to find that spot, that's the slope. And so 4 over 2 is 2. And so it's either positive 2, this way is positive 2, this way is negative 2. These are the equations of the asymptotes. All right, try number 8, and then we'll be done.